Hi everyone, Nick Wheeler here again. In this video we are going to be doing a simple overview of the heat treating process on the Joe Paranee Bowie knife blades. At this point the high carbon steel blades have simply been forged to shape and no other work has been done yet. And essentially what that means is it's just a knife shaped object right now. If we were to finish this out, grind it, polish it, put a handle on it, it would be absolutely worthless. It would be totally just junk. In order to make this have any hope of being a high quality, high performance cutting tool, the blades have to be properly thermal cycled and then hardened and tempered. There are a few key elements, really key elements, that will make or break the performance of a knife, sometimes literally. And out of those elements, hands down, the most important one is one that you can't see in the finished knife, and that is the heat treating. And I think of it a lot like the wiring in your home. Once the sheetrock is all buttoned up, you can't see the wiring, but it sure as hell better have been done right, or you're gonna have all kinds of problems. So the way I start this, the very initial step for me in my shop, is to remove the forged scale from the blades. And it's a very simple thing. I just pile the blades up in a plastic container and then fill it up with regular household vinegar and let them soak overnight, and the vinegar will actually just eat through the forged scale, and the next day I can just scrub them clean with the Scotch-Brite pad, and it's really simple. So at that point they are ready for the thermal cycles, and in my shop I do that with a digitally controlled molten salt bath. And I know that sounds kind of weird but it's actually a relatively simple thing. It's a tool that I built 13-14 years ago that it just gives me very precise temperature control over the steel, and it's a really nice thing to have. So like I said, they are just about ready to move on to that. Once we do the initial thermal cycles, the grain structure in these blades will be set up very nicely for me to go over and do all the rough grinding and make these look more like a knife blade. And once they're rough ground, they will be ready to move on to the actual hardening and tempering. But the first thing we need to do is fire up the salt bath and do those initial thermal cycles. So let's go get started. This is the salt bath furnace that I mentioned earlier. It's a relatively simple thing that I built, but it works extremely well. We have a propane line that comes in right here, a needle valve which really wasn't necessary, but it was something I put on. The gas flows to a normally closed solenoid valve, and then I have an emergency shutoff, which is just a ball valve right here. The gas propane, it flows through this line and it comes over here and it mixes with air, which is brought in by a squirrel cage blower, which is underneath. They mix, they come up here, and they will burn at the end of the burner tube, which is inside of this. This is basically a vertical forge, just like the one that I forged my blades in, except for instead of having doors on the front and back, it's got a chimney on the other side and a opening in the top for the salt. Then right here is the brains of the thing. This is a Wattlow digital temperature controller. It's all off right now, but we input whatever temperature that we want this thing to run at with this controller, and it's read by this thermocouple. And a real simple analogy of how this operates: if you take your finger and you touch a hot stove, your skin and everything else in your body sends a signal to your brain saying that's hot, I shouldn't be touching this, and you pull your hand away. This works in a real similar fashion. This is a K-type thermocouple with an Inconel sheath, so it stands up to really abusive environments. This thermocouple goes down into the molten salt. As you can see, it's got a lead that goes to the controller. This thermocouple will read the temperature of the salt, and it sends a signal to the brain, which has been programmed for whatever temperature we want. And the controller slash brain, it will tell that solenoid, that red thing, whether it should stay closed or open up and feed more gas into the furnace. And it's very simple in the overall operation, but it's really nice, because what that allows is it will climb to a temperature, it will get close to the set temperature, it will slow down, and then it will fluctuate the gas on and off and allow you to maintain that temperature with really accurate control. Now the salt vessel itself is right here. This is a 316L stainless steel tube that was TIG welded up by my friend Kelly Couples. And then what you see sticking out of it, this is a tapered stainless steel rod. And the reason for that is very simple, but it's a good reason. The salt at room temperature is solid. For those of you that grew up in a small town like I did, it looks like a salt lick. And no, it's not just household salt. This is actually called New Sol. It's from Heat Bath, and it is a commercial grade heat treating salt. It was very specifically made for exactly what I'm using it for. So anyway, the salt is solid at room temperature, and as we learned in physics, when things heat up they expand. Well, if the salt becomes molten right around 1200 degrees Fahrenheit. If the salt in the lower part of the tube were to become molten and expand, and you still had a solid cap of solid salt at the top, you basically have the makings for a bomb, because that expansion has to go somewhere. And so this tapered rod, when I'm done heat treating each time, and the salt is still molten, I just throw this in here, and it does run all the way to the bottom of the tube. And so then before we fire the salt up today, I'll yank this tapered rod out, and that creates a vent through the salt. And so if that salt in the lower part of the tube does become molten first, it has a way of venting. It will just sort of percolate up through the hole that this rod will leave in the salt. So it's a really simple thing, but it's not something that should be overlooked. So anyway, that's the salt bath, and let's go ahead and get it going.
salt in the lower part is molten now, and it's climbing up through that hole that the tapered rod left. So, and you can see there's still a very solid cap of salt on the top everywhere except for where that rod was. So hopefully that shows why it's so important to have that in there. Here you can see this lower number is our set temp, the one that we're targeting, and the one in red is what the current temperature of the salt is. So this is beyond the temperature of it melting, so it's molten in there right now, but it's got a few hundred degrees to climb still before it reaches our first target temperature for this.